it's loud. I'm Eli Shapira from Drive Your Auto. I'm Director of Innovation there. And I'd like to present you the NetApp in a 5G ASP concept, which enables autonomous vehicle deployment basically at the end. Now, you would ask, why would we need the enablement for autonomous vehicle? Autonomous vehicle, they are autonomous. So why would we need someone like Drive You or some company like Drive You to enable autonomous vehicle? The problem with autonomous vehicle is it's not fully autonomous, and it's probably not going to be in the next visible future because of pictures like I show on the right side. You can see that this picture is even hard to solve for a person. You will not solve it like in an instance. You will need to think about what to do, and of course it's much harder to a computer to understand what kind of solution it needs to solve right now. For example, you can see that this officer just showing something to the person in the person language. We are using a lot of body language to show some people what to do. And in this case, the officer just shows stop, but the autonomous vehicle maybe not be able to understand what stop is. And it will have to do some kind of decision, and it might be faulty. So basically, the whole world understood that we need a human in the loop in this case. And human in the loop, it is being achieved by teleoperation. So as you can see, many countries in the world already understand that we need to do some kind of regulation in these terms to solve the edge cases of autonomous vehicles, misunderstanding of the situation, and to help solve the situation by involving a real person basically a teleoperator. Now, what teleoperator is? Teleoperator is a human who actually monitoring the situation of the vehicle, receives and perceives the situation as a person, senses the environment by visual and other sensors, and decides for the vehicle what kind of solution needs to be taken in this specific case. And by decision to be taken, it may be driven, or maybe some kind of additional solutions like advisor to move right, move left, to continue straight, or whatever. But in the current state, it is easier to vehicle to understand direct resolution of the situation, meaning throttle or turn right, turn left with 13 degrees of wheel angle. So this is basically the teleoperation, and it requires a few different, there are a few different requirements for teleoperation in a field. The requirements, of course, based on wireless technology, like 4G, 5G, and different other technologies. So the requirements are quite high. We need a high resolution video. A high resolution video takes a lot of bandwidth. We in Drive Your Auto, we do compress this video, but it is not being compressed to like unseeable level. We need to maintain some kind of visibility to the operator. The operator needs to perceive the situation in the best way. So we have a limit for compression. Basically, we have a limit to the bandwidth being transmitted from one side to another side. And due to this high bandwidth requirements, the solution is actually may not be good enough at one network, and even not 5G, because 5G may provide you a high bandwidth network, maybe low latency, but not altogether, no low latency and high bandwidth. And now, why I'm talking about latency? Latency is a more complicated issue than people think. It is not comprehensible before you actually see this issue of the latency. Try to drive the car from a distance, you will experience a latency. With ultra low latency, you will experience a latency as like you are sitting inside the car. But it is not zero. And once you will increase this latency, it will be harder and harder to control the vehicle from a distance. So you also can add some kind of reliability issues. So no network, no wireless network is actually fully reliable. It's not 100% reliable. You're losing packets. So once you lost a compressed packets, then you lost the full frame, basically. So what we do, we distribute the packets among multiple networks and among multiple services to promise the fastest and most reliable and lowest bandwidth, by the way, due to this distribution of network usage. So you can see that in some places we actually measure that, and you can see that the reliability of the network is not stable. You can see some streets with a good connection, good reception and transmission from the station. Just to mention that we are using a lot of transmission from the station, less to be transmitted to the vehicle itself. So in some places the reception is good, but the transmission is not. So we map this transmission in some places, and you can see the situation is terrible, and not because of operators. It's not the faults of any operator, it's physics. There are some kind of different physical effects going on with the RF signals to help us control the vehicle. So what we do, we actually solve the situation by distribution the packets among the good networks. We analyze the network, we understand what kind of situation on a sub-millisecond basis, what is the network situation at this specific point, and we solve it. We put one packet to one network and another packet to another network, and it can be two different modems in the same network, but they will behave differently because of the antenna positioning on the vehicle itself. One antenna is connected to one band station and another to another, and it can be the same operator. So we actually analyze the situation and enable reliable, low latency, low bandwidth, by the way, connection to the operator, and enabling by that control of the vehicle in a low performance condition with a high safety threshold. How it is connected to 5GSP? 5G is a bunch of technologies. It's a lot of technologies which can help us solve the situation in a more efficient way. We need to use additional new features of the 5G and to experience what kind of solutions we can provide with the 5G technologies and the 5G stack. But since 5G is a new technology, we need to test it, we need to try it. There are a lot of hypotheses in the research area, but implementations are not so simple. 5GSP actually help us to solve the situation. In 5GSP we can try to do some solution we see in the future as a solution for 5G and try to develop it and deploy it. But the deployment is not really easy in research networks. So in 5GASP, we actually use the deployment, and we can try and deploy our solution much faster than if we would be doing without it. Now, I'm representing two different use cases here in 5GASP. One solution is only monitoring of the vehicle video stream, and another solution is also the control. So we have two actual NetApps with each and every one with different challenges for the NetApp. And the NetApp for only monitoring is just to transmit the video stream. The NetApp with control, it's not only to see the video stream and to transmit it to the operator, but also to send back the commands over the same or maybe different passes from the whatever was received from the vehicle. And this, by the way, connects to the previous NetApp we are talking about, the URLLC case. Once we have a low latency connection, at least at one direction, maybe we can solve at least half of the problem of the control loop. The control loop, it should be really, really quick. So to have this control loop really quick, we need to put the operator as closer as possible to the vehicle, but we can't. The controller needs to be a bit distant. So what we do, we actually analyze the stream from the modems. We decide what kind of modems, what kind of medium is better for the specific case, and grade it according to the performance in the sub-millisecond basis. And by that, we can also try to correct the issues we had in the medium before it is got to the operator and got back to change the situation of the same modem. So we aggregate it on the edge, we correct and grade the modems, and then we aggregate it in the cloud and send it to the operator.
So Eli, just one question from the chat. Am I right to understand that your service runs or may run on the edge local wireless side of the network to minimize latency? This was...
Part of the service can run on the edge. This is what we're actually trying to do in 5GASP. We try to run the part of the services which aggregates and grades the modem, and another part of the service runs on the cloud or at the operator premises.
Thank you. I wanted to take the timely. Go ahead.
Thank you. So this would be the really high-level schematic diagram of what's going on with both NetApps. I did not distinguish between two NetApps for this case, just to explain the high-level diagram of what's going on, where we have one vehicle is being monitored through the not really important, not really mission critical and latency agnostic medium, and another vehicle which is not only monitoring but also controlled should be working through the specific service we are talking about. So you can see that it is running through the edge, corrected, reassigned, realigned, and sent to the aggregation also NetApp, which can sit in the core on the cloud, and showed to the operator. The pass back is the same pass as it was before that. This would be it. Another question, if somebody would like to ask?
Yes, so I don't think it's working, but is it? Okay. So you said something about avoiding collisions or something, right? At some point, am I right? Or
collisions not between the vehicle, between the packets, because some packets can be reordered and duplicated.
Okay, okay. But you said something about the, let's say, multiple connections, right? So in order for the packets to get, let's say, in order for you to not have packet loss, right? You would need to have multiple connections, right? So you would connect to operator 1, operator 2, mobile operator 1, operator 2. But what about, I don't know, other types of connections? Like, would you consider, I don't know, getting the packets through other wireless medium like Bluetooth Low Energy or Wi-Fi or something? I don't know. I think Wi-Fi more than Bluetooth Low Energy because, yeah. I mean, or just mobile networks. That would be the question.
Yes. First of all, thank you. It's a really good question because we are not doing only this part of communication. This is what we're doing in 5GAS. We have also another projects with satellite communication, for example, for a long-haul connection. We have a Wi-Fi. We have a few low bandwidth projects like working with LoRa together with that. Each and every one has different challenges. And in the case of 5G, we created a small test and we understood that the latency of URLC is actually different than what we expect it to be, and it's different not in a good way for us. It created a different challenge for development for us. So while we mix and match different technologies, and that's connected to your questions actually, while we mix and match different technologies, we understand that the challenges of our internal algorithm, which is patented and great, but in real life it will behave differently. So while distributed in a 5G network, we understood the challenges, the initial challenges. When we will finish distributing that using 5GAS, we will find another additional challenges with mixing these technologies and seeing how, for example, latency or reliability of specific medium like 5G will influence our internal algorithms, and by that we will improve it and optimize it even more.
Another question from the chat. Since you utilize the edge, does the service instance at the edge follow the car's trajectory? Would mobility predictions be helpful in this case?
First of all, a great question. Yes, this is what we are discussing internally with consortium members because we have different applications which predicts and helps us actually to create and keep the connection running even through the roaming, even through the handovers. So yes, it will be helpful, and for that we're using actually specific Mac interfaces to utilize this functionality and to connect this two different NetApps in our case, but it can be a totally different additional NetApp which helps us to solve also the situation and can be combined together through the standard APIs.
Thank you. Do we have any other questions around here? Good. Thank you.